Welcome to Chrome Guided Smile educational course on the Osteotomy Guide and the Carrier Guide, two critical components of Chrome. I like to think that every component of Chrome is critical. These two certainly are high on the list of critical components. So we're just going to talk about these two today. We're going to try to, this time we're going to blend in a little bit of surgery and a little bit about just the components themselves for quality control and understanding all of their attributes. The osteotomy guide, there'll be some things that are just kind of obvious about an osteotomy guide, but the first item is that the use of it is to control the handles or the drills during osteotomy creation. Some kits have spoons and handles, and some just use a set of drills, and we're going to cover both of those. The osteotomy guide also controls the depth, a key feature. It has to control depth prolongation, which is why Chrome Guided Smile can only be used with a with a guided kit, not necessarily a fully guided kit. And we'll address that as well. And it does, the osteotomy guide controls the indexing of the implant on the sites where there's a hex. Where it's round, it does not need to control the indexing, but on the hex it does, because the hex directly coordinates with the flat side of the implant. And then in some systems, the implant is also placed through the osteotomy guide. Not all, unfortunately, but that's the main difference between guided surgery and fully guided surgery. Fully meaning that the implant is also placed through the surgical guide. So just like we've done with the other programs, what we want to do first is just talk about the inspection of an osteotomy guide when it's received. And when a technician goes chairside, this is one of the first things we do. We take all the contents out of the chrome case. We assemble the parts. We make sure the plungers fit. We make sure everything is assembled. We make sure the right kit has been, the right guide has been sent to the right patient. But kind of go through all of these steps. You want to make sure that the osteotomy guide is flush with the fixation base. Sometimes you'll see a little bit of a bounce between the two. That's not the end of the day. We do like it to be flush. Really, these chrome locks, once plunged, should hold down the loop inside of the chrome lock box. It should be a snug fit. But if there's a little bounce to it, it can be held down at surgery. Of course, we don't want an excessive bounce. You can adjust the loop. If the plunger is going in tightly, check to make sure that it's also going in tightly with the osteotomy guide out. So remove the osteotomy guide, push the plunger in and out. If it's still tight, then just use some mineral oil, and that should loosen it up, and just push it in and out 5, 6, 7, 8 times, and it'll loosen it up. If it tightens down quite a bit, it becomes tough to plunge with the osteotomy guide in, then you can adjust the loop inside of here. Just take a carbide and adjust it just a little bit. Be careful not to adjust it too much. You don't want to introduce any bounce into the guide, into the osteotomy guide. You also want to take the spoons or the drills and fit them into each site on the osteotomy guide. A part of that is knowing the guided kit, because different drills and different spoons coordinate with different size implants. So know the kit and then do the test. You'll actually take the guided kit out of the box and pretend like you're doing a surgery. And then you can also look at the GSI images, which I'll show an image of that shortly, that just compares what you physically received compared to what you digitally received to verify. And then just in the rare occurrence, sometimes like lower anteriors, sometimes maxillary centrals, the implants are very close, maybe a central and a lateral, are very close. And sometimes they're so close that we have to either make 2 osteotomy guides, or we have to do some significant adjustments to the site or the wall of it digitally, and it's tough to fit a spoon into the adjacent sites. So that's something that we test and you'll test at the laboratory. But the doctor can also test it because there may be two guides. One guide for instance, number 24 site, and one guide for site number 25. They're so close that you cannot make them both in the same osteotomy guide. So one tool is one trick is to take the physical osteotomy guide out of the package, compare it to the image on the GSI report, and you'll just be able to instantly tell to make sure that it's the same case. But one thing you can also do is assemble the fixation base on the bone model using the pins, place the osteotomy guide into the fixation base, and then just visualize how this osteotomy guide is going to interact with the bone. And even you could even take some photographs of it, but you'll just immediately know that this is what it should look like once the bone is reduced, and how the osteotomy guide is going to interact with the bone. You can also use calipers to measure the inside diameter of the osteotomy guide. This is very precision design. You can see this site here is a 5.0 inside diameter, which means that the actual dimension will be 5.1. We make them just a little bit bigger to accommodate the spoons. That's how master tubes are also designed. So chrome might look a little bit rough on the surface. The integrity of the surface and the size of it is designed to accept the spoon. So you can see here, this is there's three different cases, but in this case here, this is 4.43 millimeters is the size of the site, and the spoon is just a hair smaller, 3/10 of a millimeter smaller. So that's we want there to be just a little bit of play. If they're ever too tight, then you can adjust the inside of the osteotomy guide, but use great care with that adjustment. It ought to be just really just buzzing it a little bit until the spoon seats. You don't want to introduce any space and wiggle into it. Now, as mentioned before, the only types of implant systems that can be used with chrome are ones that include, among a couple other things, a guided kit, fully guided or a guided kit. It must have, for instance, up here, it must have a set of spoons or tools. Most of these systems here have a spoon or a tool that fits into the guide. Hyasin has a set of drills, so there is no spoon. With a spoon, the spoon goes in, the drill goes in. So that's, it's machined very precisely, but it does add a little bit of, a little bit of variable, can add a little bit of wiggle with a drill and a spoon and our osteotomy guide. So there's really three variables there. With Hyasin, with Megagen, as a few others, the drill fits right into our osteotomy guide, no spoon. That's a really a very simplified way to complete the surgery and to be sure that, of the accuracy. So these are 15 guided kits. Here's more. These are all the guided kits that really work with chrome right now. When you're uploading your case, when you're writing your case up, these are all in the drop down. You just pick which guided system you're using. There are others on the market, and there's more coming to the market. And in order to add another guided kit to the system, chrome will need the physical guide, the physical kit, so that measurements can be taken and we can set up the size and the offsets, the prolongation, etc. So that's important that we have the physical kit. These cases can be quite complex. This is a Navigator kit. This is one of the most complicated of the guided kits that we use. You can see all the parameters that the doctor has to know: prolongation, master tube, and implant mounts and shaping drills. You don't have to use all of these tools. However, it's very good to know the guided kit that you're going to be involved in, and to make sure that perhaps you and the doctor have had a little chat about the surgery to be undertaken. There is a difference in some osteotomy guides that come to surgery. The 6 systems on the left-hand side, chrome includes sleeves. So in other words, we designed the osteotomy guide to accommodate the master tube of the OEM company. And so therefore, in other words, the osteotomy guide comes, the sleeve is then cemented into the site. And this is very important because these come in all different sizes and colors, and it's important to know which one goes in which, in which site. And not only that, you want to make sure that it's flush. You want it to be totally flush. Maybe you have to adjust the top, top of this a little bit when you're seating it. But also when it's cemented in, just watch out for the rotation. I have a couple more slides on this, but there's a notch here in the sleeve that's going to correspond with the flat side of the osteotomy guide. And it doesn't necessarily have to be on the facial, but it does have to line up with a flat, because for instance, this is BioHorizon, and their tool is going to stop rotating, will be stopped rotating as soon as it meets this little notch. And that means the implant is indexed for the multi-unit abutment and the temporary cylinder. So the temporary cylinder is going straight up and down. That is very, very important. You can see this is this difference. This is BioHorizon, I believe here. I believe this is Straumann BioHorizon. But there's a notch and it coordinates with the flat side. And I'll show some more images of that in a minute. But turn the volume down here. But you'll notice I'm just running through all these different systems that Chrome has. We offer sleeves and guided kits and systems for all these different implants on the market, which is just really a daunting task to keep track of all these parts. So on the left are sleeves and spoons that we offer, that Chrome offers, and then all these are guided kits and spoons and so forth for QCing. Those are. It's really important that that the right tools are on hand in order to check cases. So this is a little bit more of a close-up of a sleeve and how it is coordinated with the notch. So if you have much experience with it, you'll know that round means straight implant and hex means angled implant. But even so, on the rounds, we will line up the flat side. You see flat side with the buckle with the notch, and therefore the rotation will stop on that notch. This is, of course, a sleeve system. And then, then there's also the drill-only system, right? So you either have sleeve or non-sleeve, but you also have spoon or not spoon. So the previous slide was a spoon and a sleeve system. This is just a drill. This is a MegaGen kit, and there is a whole kit of drills that all have the same master tube hub size. So every drill that you take from this kit will fit into the osteotomy guide, the Chrome osteotomy guide. So then it's just a matter of following the depth. I won't go through the particulars about this kit, but you'll essentially follow left to right, making the osteotomy larger, but you won't have to swap out spoons in order to do it. It's a very simple technique to use their kit. This is a spoon system, which means it doesn't necessarily have to have an OEM sleeve on the inside, but you do have to drop the spoon in first, and then in goes the drill. And that's how you control the site creation. And then there's a little bit of math involved with the prolongation. The top of the Chrome sleeve is at one distance from the apex of the implant, but then the top of the spoon is another distance. So there's a little bit of math that goes along in that. But during surgery, that does not have to be considered. That's already been taken into consideration. Place the spoon and drill. With all systems, with all implant systems, there is a means for controlling the rotation of the implant. not necessarily, as mentioned before, placing the implant, but the rotation of the implant and the indexing of it. So on this is again a Megagen. We have a lot of images of Megagen because we have KOLs that do some really nice documentation with their kit. But with their kit, the implant's placed on the implant mount, the implant is driven in through the guide, and there's an intimate fit with the driver, and then the flat side in this system just happens to be this green concavity, which lines up with the flat side. And one thing to watch out for, go back up here, is that this is a little bit of an older kit, an older guide, as in it was probably made last year, where there's no notch. Every case that goes out should have a notch on it now, which means that the concavity of this will match the notch. And I mention that because sometimes in a bloody surgery or deep back in the posterior of the mouth, it's kind of tough to see if this flat side is lining up with the flat side of the hex. But if there's a little notch there, it's a little bit easier to see. And then I think finally is the control of the implants. Of course we control the drills. Of course we can control the rotation of the implant, but can you control the implant as it's being placed into the bone? Not all systems allow it. For instance, this hub is clearly not fitting. See a little animation here. Well, I put it in a little bit of a wrong place, but there's a gap right here, which means that the implant is going through the guide, but it is not being controlled. So this is more of a freehand placement of an implant following the osteotomy site that was already drilled. If controlling the implant is important, then be sure that the guide that's being used is a fully guided kit, and that part of it is clarified, fully guided. Oh, here's the image. So you can see clearly that there's just a gap. It's not meant to control the implant. On the left, I believe it's a Nobel system, and in this system, the hubs all fit into the guide, and that the that the osteotomy guide is controlling the placement. Of course, on the well, I was going to mention the indexing, but kind of already covered that. That was the osteotomy guide. And please, if you have any questions on the osteotomy guide, please write them down. We'll have a Q&A session at the end. As far as the carrier guide is kind of the next step in the sequence of completing a chrome case. The main purpose of the carrier guide is to support the prosthetic. But often the carrier guide is used earlier in the surgery. When the fixation base is in, the bone has been reduced, the carrier guide is often inserted into the fixation base to see if it has a passive fit. It can help determine if there's enough tissue retraction and if there's enough bone reduction. Because if it fits, if it seats, then there's enough bone that's been reduced. So that's kind of a nice technique to use. It can also hold back the flap, hold it back at bay. Not the best technique, but it can be used if the tissue is not too thick. It also, and I'll show another image of this in a minute, simulates tissue thickness. That's one of the key benefits of the carrier guide. It also delivers the nano ceramic prosthetic and the rapid appliance during pickup. And it can aid in the direction of the multi-unit abutments as they're screwed into the implant. And I'll go over each one of those items. So the first is what was mentioned earlier. First on is seating the carrier guide as soon as the bone reduction is finished. Now this case is flush here, flush here. This is a gap. This is not. This doesn't mean that the carrier guide is raised. It's just a visual gap, but it's fully seated. And if it's fully seated, then the tissue can be then it can be removed and move on to osteotomy guide. We have seen where the carrier guide is used to retract tissue, but Often, most of the time, the lingual tissue is a very thick keratinized tissue, and using the carrier guide to hold it back is not the best use of the carrier guide. In fact, it's much better that when the tissue has been flapped back, to go ahead and put a stitch in and hold it away from the carrier guide so it doesn't put pressure on it. Add a stitch. Inspection of the carrier guide just follows just a few important things. One of the most important is that the carrier guide fits passively into the fixation base, and that it's very important that if it is not fully seating, to ask why. Why is it not fully seating? Because at quality control, at Chrome and in the laboratory, these parts have been tested in a doctor's office. They should have been tested, and this should fit passively. If for some reason it's being held up, there is probably something down inside of the Chrome lock box. And sometimes these little loops will break off because it was removed in a wrong trajectory. And then it's down inside, lodged in there, and now the Chrome lock cannot be, the carrier guide cannot be seated. So that little part has to be removed. That's not the end of the day. There's still 2 left. But it is really important that when the carrier guide is ejected or removed from the fixation base, that it's moved vertically. I put some arrows on here. We all know what vertical is, but that it's taken straight up and it's not rotated. You don't want to break the carrier guide because it really needs to be fixed in the mouth for really kind of a long period of time while doing the conversion and for seating the abutments. Make sure I covered, yes. Questions on that, please ask at the end. So some of the key points of the carrier guide. One is it gives us the tissue thickness. So from the bottom, or in this case, the top, the apical part of the nanoceramic to the bone surface is 3 millimeters. That is the thickness of most people's tissue, and we take averages. I know that there's a little more of a perio approach that's available. You can do bone sounding if you want to determine the actual tissue thickness. That's an option. But at Chrome, it's chosen that it's just going to be 3 millimeters average. So the thickness of the outside of the carrier guide is 3 millimeters. The distal portion of it, the part that's going over the implants, is not 3 millimeters. That's a much thinner wafer, but this is 3, and that's what it's simulating. On top of the carrier guide, there are carrier males. Be careful with these males. I don't see them break too often. In fact, really rarely. But if the rapid or the nanoceramic are stuck onto it, or you see a gap between the prosthetic and the carrier guide, adjust the inside of the prosthetic, adjust the inside of the rapid appliance. Don't adjust the male, because the thinner it is, the weaker it is. Also, holes may need to be adjusted on the carrier guide during surgery, and I'll show some pictures of that shortly. There's a technique for shimming. If you're at the very end of the surgery, you place the prosthetic in and the patient has an open bite in the posterior or hitting somewhere early, you can always shim and lift the prosthetic up a little bit. Of course, you don't want to lift it too much. And that trick is kind of really a conversation in itself. But if you're going to shim, then you can cut half of these males off, or even a little bit lower, maybe 2/3 of them off, so that the shimming does not break them or does not torque them. A little tip. And then just always be careful with the loops. If the loops break, they cannot be repaired. They have to be remade, or the carrier guide just has to be manually held into place. In surgery, as mentioned before, sometimes the carrier guide needs adjusted. Now, I know that some doctors and even some lab techs will just adjust these and open them up before surgery even happens. I suggest not to do that, especially if you have a lot of straight implants. If they're straight, really the temporary cylinder and the multi abutment should wind up right in the middle of these carrier guide sites. Should not be a problem at all. Maybe on an angle, if you have a lot of experience with where to rotate, where to adjust it based on the rotation or position of the temporary cylinder, you can adjust it in advance. But frankly, it's pretty simple to adjust, you know, kind of on the fly when you're in surgery. Now, one key feature of the carrier guide is the notch. I think everybody's been educated on the notch, but I'm going to go into a little bit of detail of the purpose of it. There will be a notch only on angled implants because the trajectory, what the notch is the trajectory of the implant. So if the implant is coming, and I'm going to do a little demonstration with blue sky, but if the implant is coming this direction on an angle, that's where the notch is going to be. This is where the thumb drive or the torque wrench is going to enter the multi-unit abutment into the screw. The screw goes into the implant. That's the trajectory of the implant. So it's all linear. That's kind of a very important thing to understand, because when you're rotating your implants, when you're indexing your angled implants, it's very important to stop on the right rotation, because one little over or under rotation of an implant has a significant bearing on the trajectory of the temporary cylinder. And I'll show a couple of examples of it. But you can see here, Dr. Towell took a nice video. It's a short video, but you can see the angle of that driver and how it goes in right where the black spot is. So that's what to look for when you're placing the abutment screw. Let me just give just a real quick demo of what I'm speaking of here. So this is the blue sky plan, and this is, you know, long after the plan, Chrome has been designed and then it's brought back into the software. I want to show this one particular implant. This is an angled implant, right? It's obvious it's an angled implant, but look at the trajectory. So there's the box. So the box follows the exact trajectory of the implant. And then of course the multi-unit abutment, the temporary cylinder will go straight up. So you can see this is a complicated case. This is pardon me, this is a lot of coordination with 6 angled implants, a lot of moving parts, and you can imagine how important indexing is on a case like this. Pardon me. Sometimes in the posterior, there is not enough plastic material on the carrier guide to place the notches, because then it'll leave just some dangling plastic back here that could easily break off. So instead, sometimes you'll see a little notch that a burr has been used, or digitally there would be a little bit of a notch placed. Sorry about that. And this is where the channel of the driver will go in, right down this channel here. The top right image is a pretty sound image of what it should look like when all the temporary cylinder is in, when the abutments are in. Yet this was an angled implant and it's not straight. Now the nanoceramic does have 6 millimeter holes on the straight, 7 millimeter holes on angled. Somewhere around that number. I mean, it's math. We use it as it's a software setting. But if you have an implant that's off by 3 degrees, 4 degrees, this manifests itself in a crooked temporary cylinder. And you can see down here on the bottom right, crooked, 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 crooked. With that many crooked cylinders, that you either are going to have to adjust the prosthetic, or you're going to have to take off temporary cylinders and abutments and torque with a hand driver the implants 3 degrees back left, 3 degrees clockwise. Kind of have to decide which way to go. But it's not a good idea to just start grinding on the prosthetic. It weakens it, and it will lead to problems later. that's one issue, is trajectory. But it can also, the trajectory of the implant, and also the hand driving of the implant as opposed to guided implants, and freehanding it into the osteotomy, also manifests itself in other problems. You can see here, this multi-unit abutment temporary cylinder are very close to the plastic. This is on an angled implant. The straights are almost perfectly in the middle. This is an angle, this is an angle. You can see that there's a little black notch here. Forgive me, I think this one's a straight, this one's an angle. And so that can be changed, it can be righted. You only have one chance to do it. Really cannot do it later because these abutments are 17 degree and 30 degree and no variables in the middle. So rotate the implant until the multi-unit abutment is going straight up and down. Otherwise, adjust the carrier guide. Don't let it put pressure on the carrier guide. Everything has to be passive. You know, here's another example, multi-unit abutment. And another key to success is using low multi-unit abutment collar heights. In the email that goes out with cases, there's a recommendation for 2 to 3 millimeters. Many systems only sell 2 to 3 millimeters. Some systems like Nobel on a 30 degree abutment, they only sell a 3.5 millimeter collar height from what I recall. That's very high. That means the collar height is going to be sticking above the carrier guide quite a bit, and it probably will end up with, with some issues for aesthetics and functionality down the road. There are systems out there with very low collar heights. Neodent, 1.5 millimeter cuff height on a 30 degree abutment, very low. Most systems offer 2 millimeters. We recommend 2, 3 at the most. And that will help with all of this at this point working properly at the carrier guide. So, you know, in summary, we're looking for predictable surgery. There are a lot of tools in Chrome that deliver this predictability, and just following some of these rules with indexing, with notches, with the hexing, with the hex timing, can just make the restorative phase so much more smooth. So we encourage everybody to just, you know, follow the instructions and have a really good Chrome morning or afternoon. Thank you very much. And if anybody has questions, I'll be happy to answer them now. And you're welcome to either voice or chat if you have any questions, please.
Hey, this is Mark. Can you hear me?
Yeah. Hey, Mark. How are you?
Good. How are you?
Fine. Thanks.
Hey, question on, you showed where those multi-unit abutments, where they are angled and you're having to grind a lot on the carrier. And then in turn, you're going to end up having to grind a lot on the temporary prosthesis. Would the reason that happens, is it because of the design, or was it because the implants were indexed incorrectly? Because we've had a few of them that happen that way.
Yeah, now that has two reasons of why that happens. There's probably a few more, but the two main are the implant was either placed a little bit too deep or a little too shallow, and therefore the position, not trajectory, but position of that temporary cylinder and multi-unit abutment are now either on one side of the hole of the carrier guide or on the other side of the hole of the carrier guide. It's usually depth, especially if your temporary cylinder is sticking straight up like it's supposed to. That means that means the implant is too shallow or too deep because it was planned properly. Now, there is there's a little issue with Chrome planning that's being addressed, and that is that in Blue Sky and really every software out there on the market, the OEM abutments are not in the library. And so anyone planning a guided surgery today is using a generic cylinder instead of an OEM multi-unit abutment. And so you can see if you don't have the offset of that abutment perfect, if you don't have it perfectly, and you're using just an averages for that hole, then the position of that temporary cylinder on an angled implant can have a little bit of a variance.
Okay. And then you said if it looks like it's way out, you're going to have to grind a lot on that prosthesis. A better option is to remove that temporary, or remove that multi-unit abutment and rotate that implant.
Mm-hmm. No question.
Okay.
Even if it's straight, the implant could be backed out a little bit, maybe a half a turn, or pressed in a little bit further, depending on where. You know, if in other words, if it's on an angled implant and it's in the posterior, and you notice that the multi-unit abutment is hitting the posterior of the carrier guide, the implant probably needs to go a little deeper if it's mesially inclined. You follow me? Because that'll bring the abutment forward. If the temporary cylinder is just crooked, then that's just a matter of rotating the implant a little bit. You know, not much, 4 degrees, 3 degrees, depending on how many flat sides that implant has. Some have a hex, some have 12 sides. You know, you may not have to move it that much. Does that answer it?
Yeah, and then you recommend putting another little black mark where you want that to, you know, where the new position of the multi-unit is going to be in relation to the carrier.
Well, the black
you're going to rotate the implant.
Nah, the original black mark is right. You know, more than likely that implant, if it's lined up on the black and the temporary cylinder is going straight up and down, the implant is just too shallow or too deep.
Okay.
And that'll change the position of that abutment.
So in that case, you'd have to move it out like a full turn to get it higher. Okay.
Yeah, you might have to, deeper or shallower. But you know, if the you know, you heard during the presentation that we don't always control. The doctor doesn't always control the implant going in, because it may not be a fully guided kit. They free-handed that implant, and therefore the trajectory is going to be a little bit different. The depth is not going to be as 100% as planned. You know, because it's really free-handed. Okay. That's really it's really a problem with a lot of guided surgery, with guided surgery kits.
Yeah. Okay. The ones we have done, they were fully guided, but we still had issues with the multi-unit abutment being pushed way to one side of the hole in the carrier guide, and then we're still having to remove a lot of material from that prosthesis. So, just
interesting.
Curious.
But the temporary cylinder is going straight up?
It appears to. Yep, and it's indexed correctly. I mean, we made sure it was lined up with the notch.
And is it? I guess the next question is: it touching the posterior or the anterior of the carrier guide? And was it
seems like it was the anterior?
Anterior, and so if it's, I mean, normally those implants are angled with the apex towards the mesial, which means that implant might be a little bit too deep. But I understand the implant was controlled when it's going in, but I don't know if anybody else out there has something to add to that. Bob, I see Bob's on. Bob's been in a lot of surgeries.
Yeah. Hi, Alan. Hi, gang.
Hey.
You know, I think a lot of times it's just, you know, I always tell the surgeons to make sure you're going in a bullseye. You know, because sometimes, you know, there's slight leeway in the going through the guide, and that implant, to your point earlier, Alan, it just goes a little bit off center.
Yeah.
You know, and you know, some guided kits are better than others, but so many times I'll just tell the doc at that time, I say, make sure you're going on a bullseye. You know, make sure, and I look at it, and if he's not right, I stop him right away. I just say you're not going in parallel to the osteotomy. And the other thing is making sure that going back earlier, that carrier is all the way seated. Like a lot of times there's tissue back there and you can still pin it in, but yet posteriorly it's still tipped up slightly. And it's just so many times you got tissue in the way of that you constantly have to tell your surgeon or your docs to make sure that carrier goes in very, very passive. And that's why we use that carrier. And we're to the point now, because Alan, you made a great point earlier about the little knobs, about taking it out. We don't mess around with it anymore. We print 2 of those. So we work 2 of those multi-guides. Yeah, we especially if you deliver it earlier, the docs are playing with them. So many times you go for the surgery and you find out one's already broke. That we always print 2 of those.
2 carrier guides.
And we QC that just as if you only have 1. We make sure they're both identical.
Yep. That's exactly what
then you
for
can
the
use,
few bucks it costs you, it's worth.
Exactly.
Okay.
But
well,
no,
it sounds like probably it was misangle out of drilling, like you said. There is some clearance right between that drill and that guide. And if they don't have that dead center, you're going to have to be off a little bit. It'll always straighten it because there is a little bit of play in the osteotomy, right? So if you're not going in centered, the carrier typically will pick up that chimney and then recenter it, but actually the implant's already off. Especially if you're in the upper, you typically see more in the upper than you do the lower because, the bone's not as hard. And a lot of times the guides could be off. And then because the bone's soft, it kind of recenters. But once that guide comes out, the implant's not really centered to the carrier or to the osteotomy.
Yeah. And then just to add one more thing, in that surgery where you're guiding the implant very well could be in the right place. But the science has not caught up with the demands of Chrome, and that carrier guide hole,
100%.
That carrier guide hole could be just a little bit off of where it should be because it's not based on that particular implant company's abutment offset.
100%, Alan. 100%. Yeah.
Right.
I mean,
I get it.
And that's the whole thing with this is that, you get to a point where you're almost waiting for the conversion side. But if you kind of watch the doc, you're figuring out. Like if you really pay attention, especially your earlier surgeries, where you can just kind of, wave red flags because, most of your docs are using the same implant time after time.
Yeah. That
you can kind of help them going forward. Just give them like little tips on what to watch out for. But, it's amazing because we're doing double arches where we never adjust anything.
Yeah.
And we're just doing a simple all-on-4 single arch, and you think you have a home run and you have adjustments.
Huh.
And to your point, Alan, it's just, it's a great science, but it's not perfect.
Yeah. Well, I'll tell you, there'll be an update. Chrome's going to have an update in the next few months where OEM abutments are going to be included in most of these plannings.
That's great.
Okay.
No, that'll be huge.
Yeah.
Okay.
But
all right. Well, thank you.
Anybody else have
sounds great.
questions? All right. Well,
Alan, as always, really comprehensive. I really appreciate it.
All right. Thanks a lot, Bob. Thanks, folks.
Yeah, thank you.
All right.
We'll see you Friday.